All right, everybody, so for our second set of notes here, we are going to be doing basically exactly the same thing. The only difference now is that our vertex won't always be at the origin. Sometimes it'll be left or right or up or down, and based off of that, we're going to have a different equation. So for our first one, another new equation to note down here. So this is where we have a vertex at h comma k, and again, a is still the distance from that vertex to the focus or directrix. And this is another example of a parabola that would open left or right. So if we're drawing this graph, we're going to see that the parabola might look like this, and then now our vertex is at h comma k. So if this is like, let's say that ordered pair there is like 4, 0, our vertex at this case would be at 4, 0. And secondly, let's add in a second point. So let's say that our focus is at 7, 0, which means that we are 3 jumps away. So that would mean that our directrix would also be 1, 2, 3 jumps away as well. Okay, so we have a few pieces of information here. So we've identified our vertex, we've identified our focus, and based off of this, we should be able to fill in our equation up here. So let's start off one thing at a time. So let's plug in that vertex. So for ax minus h equals y minus k squared. So again, that's h and that's k. Just directly plugged each of those in. And then next, we need to see what is our distance from our focus to our vertex. So we want 1, 2, 3 directly to the right. So distance from there is 3. So our a value is 3. So 4 times 3 times x minus 4 equals just y squared. Y minus 0 is just y. Okay, so evaluate this. 12 x minus 4 equals y squared. So that would be what that equation looks like. And again, our distance is positive. We open to the right. That's why we have a positive a. So again, this is positive. It opens to the right. So that's one example. So again, you might be given any or none of these pieces, and your goal based off of what you're given is to fill in everything so you can get to your final answer form on the bottom here. So again, focus on where that vertex is, focus on its distance from focus to vertex, and then you'll be able to find